In this lesson we'll go over something called damped oscillation. So here's an example of where we'd want to have oscillation be damped. Um, in a car, if the car hits a speed bump, the tire has to move up, and then the car would have to move up. So if there was only a spring in supporting the car to the axle, then when the tire pushes up, it would push the car up, and then the car would bounce on the spring like this. So we don't want that, and that's why they put a shock absorber in there. So here's a piston that has fluid in it, and when the tire pushes up, uh, the car would just move a little bit and then flatten out because there's friction in the fluid inside of the shock absorber. And we're going to talk about this type of graph where if we had axes, then the uh, the graph of sine, instead of looking like this, would be within the other graph. So maybe this could be 1 over x, and it would uh, be damped down to 0. Okay, so this is called, when we look at just the graph is called, this behavior is called damped oscillation. And when we see actual objects moving like this, it's called damped harmonic motion. Alright, and we can use the same transformation graphing strategies that we've been using. So let's try previously, when we looked at a transformation, this would be a constant, and we would always multiply the y value by a constant, but now we're just going to be multiplying the y value by a changing value, but we still can follow all the same steps, and this is called the damping factor. So these are the points from the parent function for sine, and then we will just modify the y value, multiply the y value by the x value. Alright, so that is an outside change. It's a vertical dilation. We're going to multiply the x values by, multiply the y values by the x value. Oops. Alright, so this says multiply the y value by x. So here's the y value, and we're going to multiply it by the x value. We get pi over 2. Here's the y value multiplied by the x value. The y value is 1, multiplied by the x value. Y value is 0, multiplied by the x value. Negative 1 times 3 pi over 2, negative 3 pi over 2, 0 times 2 pi, 1 times 5 pi over 2. And we'll just go negative, start at the origin, and pi over 2 to pi over 2. At pi, we'll go to 0. 3 pi over 2, go to negative 3 pi over 2. This will be pi, there's negative 3 pi over 2. At 2 pi, at 2 pi we should be at 0. And then 5 pi over 2 goes to 5 pi over 2. On the other side we have negative pi over 2 to pi over 2. And then it'll be symmetric like that. And another characteristic of this graph is the boundary, or the upper and lower limits of the sine graph is the graph y equals x. So if we graph y equals x, we know that this graph will be within that. All right, and let's do the same thing with this. We still can use the same points, but every y value will be multiplied by this done to the x value. So go ahead and try that one. Pause the video. And then we'll just multiply all the y values get multiplied by x cubed over 2. And so we keep the same x value. And we're going to go -1 times this cubed divided by 2. I just have to get this one value, and the other ones are already calculated. So this will be about 1.9. And okay, we can go -1 times this. Negative times negative is positive. And then we're going to have 0 cubed over 2 times 0. Pi over 2 cubed divided by 2 times 1. And we're going to get about 1.9. And here we're multiplying anything times 0. We're going to cube this, divide it by 2, multiply by -1. So that's -52. And then we go back to 0. So we know we have to go to -52, +52, and so we're at 0, 0. Pi over 2, go to 1.9. And then over here we'll be at 1.9 on both of them. Go back to 0. At pi we're at 0. At 3 pi over 2 go down to -52. And then back up to 0. Alright, pause the video and try that one. We have to multiply all the y values by 1 over the x value. 1 over x times the y value. And so we're going to go 0 times 1 over negative 2 pi, and that's 0. So every time we have a 0 for the y, we'll have a 0. We'll still have a 0. And here we're going to have the reciprocal of this times 1. So that's negative 2 over 3 pi. The reciprocal of this times negative 1 would be positive 2 over pi. And the reciprocal times 1, 2 over pi. Reciprocal times negative 1, negative 2 over 3 pi. And let's just get some decimal values. We have negative 0.2, 0.6, and then 0.6 and negative 0.2. One correction. Here we're going to be multiplying by 1 over 0, so that's undefined. So let's make that undefined, and that means at 0, it would be hard to tell from the table, but this is just going to be a missing value. And let's fill in the rest and see if we can figure out what that y value would be. So pi over 2, we're at 0.6. Pi over 2, we go to 0.6. And at pi it's 0. 3 pi over 2 is negative 0.2. And then back to 0 with the same thing over here. And to figure out what's happening at 0, we could just get closer and closer. Let's choose, we could choose x values that are really close to 0, and we would see that the graph continues and it approaches the y value of 1. So there's an open circle there, and it goes like that. Alright, so just remember to use the points for the parent function of cosine, but it all looks the same here. Pause the video and try that one. And then we're going to have 1/4 x times the y value. So 1/4 of this times that. We have a negative times a negative, positive pi over 4, 1/4 of pi times 1. Then we'll go 1/4 of this times 0, it's still 0. 1/4 of 0 times 1, and that's 0. Again, we multiply times 0, and then it's going to be 1/4 of pi times negative 1. So that's negative pi over 4. 1/4 of this would be 3 pi over 8 times 0. And 1/4 of this would be 2 pi over 4, or pi over 2. So at negative pi, we'll be at pi over 4. At negative pi, pi over 4. Negative pi over 2 will be at 0. 0, 0. Again at 0. At pi, we go to negative pi over 4. At pi, negative pi over 4. And 3 pi over 2, we go to 0. At 2 pi, we're at pi over 2. And we know we're not going to have a horizontal line here, and the graph is going like this. So then we can just assume it's going to go like that, and this is at pi over 2, so this will be at negative pi over 2. And there are just a few problems like the previous lesson in the assignment, so let's just review that. They're pretty easy. And all we have to calculate is b based on the period. So we know that the period of tangent or cotangent is pi over b. We need to calculate b, so that's pi over p. And the period is pi over 3, so b is pi over 3, pi, 3 over pi. We're dividing by a fraction, so we'll multiply by its reciprocal and we get 3. And then we have a tangent b x minus c plus d. A is 1, and b is 3. C is pi over 2, so we'll go minus pi over 2, and the vertical shift is negative 2. So that's all we have to do. Same question, and we'll do the function is secant. The period is 3 pi. Phase shift 2. And vertical shift 3. Pause and try that one. The period is 2 pi over b, because only tan and cotan have the pi over b. Everything else is going to have 2 pi over b. So we want b to be 2 pi over p, and the period is 3 pi. So b is 2 pi over 3 pi, and we get 2/3. So y equals a secant b x minus c plus d. A is 1, b is 2/3, x minus the phase shift plus 3. Alright, and we'll stop there.